Hello viewers, welcome to this video on geometry test. This guidance video is happily presented by the PG and Research Department of Physics of National College. Both the department and the college feel happy in sharing this as an e-resource to the aspirants of these prestigious examinations. This is Dr. T.V. Sundar explaining you some of the geometry concepts in this video with some illustrations. At the outset, try to know the significance of geometry cosines. You look at the question, why geometry cosines are being often asked in the competitive examinations. The reason is simple. Studying geometry provides the students with many foundational skills and helps them to build their logical thinking skills, deductive reasoning skills, analytical skills, and the problem solving skills. That is why the geometry-based questions are very common in many of the competitive examinations. You look at the first question on the screen. The maximum area of a right-angled triangle inscribed in a circle of radius r is 2r square by 2, root 2 times r square and r square. How to solve this? Look at the reference figure where a right-angled triangle is drawn inside a circle. As per the given question, the right-angled triangle with the maximum area that could be inscribed in a circle would have its hypotenuse as the diameter of the circle. This is what shown in the reference diagram. Also, such a right-angled triangle so constructed would definitely be an isosceles triangle having its sides in the ratio 1:1:√2. So using the properties of right-angle triangle, we can easily elucidate that the side of the triangle as root 2 times r. Now compute the area of the triangle using the formula half into base into height. That is half into root 2 times r into root 2 times r, resulting in r square. The second one is on trapezium. At what horizontal distance from A should a vertical line be drawn so as to divide the area of the trapezium in the figure into two equal parts? Here A and B are given as the lengths of the parallel sides of the trapezium. Let us start the solution of the problem with this reference diagram. Let me put the vertical of the height h, that of the trapezium, at a distance x from the point capital A in the figure. The position of h should be placed such that it exactly divides the area into equal parts. That means the area of the rectangle formed with the sides h and x will be half of the area of the entire trapezium. That is half into a plus b by h. Writing all these things in the form of an equation, we have the area of the rectangle x dot h is equal to area of the trapezium half into a plus b into h whole divided by 2. Solving for x, we get the length scale as a plus b by 4. This problem is based on the properties of arcs of circles. The question is, a circle O is given with angle PAO 40 degrees and angle PBQ 30 degrees, and the outer angle AOB as 220 degrees. The arc APQB is formed such that angle AOB is equal to 220 degree. To solve this, simply use the property formula. The angle subtended by an arc at the center is twice the angle subtended by it on the remaining part of the circle. By using this property, we see that angle AOB is equal to 360 degree minus 220 degrees, 140 degrees. Hence, the angle subtended at the point, any point on the circumference of the circle will be half of this. That is 140 degree by 2, that is equal to 70 degrees. Hence, the required answer, angle AQB is equal to 70 degree. Even angle APB is also will be 70 degrees only. This fourth one requires a little bit of mental picturization. A wire is bent into the shape of a square enclosing an area M. If the same wire is bent to form a circle, the area enclosed will be what? Definitely, the areas will be different as the shapes are different. But remember, a wire of a particular length in one case forms a square and in another case it forms a circle. Look at the reference diagram. Let us take L as the side of the square. Then the wire, total length of the wire is equal to 4L. Then area of the square M is equal to L dot L, that is L square. Now this wire of length 4L is bent into the form of a circle. When done so, it forms the circumference of the circle. Therefore, 2 pi r is equal to 4L, giving the radius r as 4L by 2 pi. Now to compute its area, use the formula pi r square and substitute the value of r. So pi into 16L square divided by 4 pi square, that is equal to 4L square by 5. But L square is the area of the square represented as M. So the area of the circle will be 4M by 5 and is given as the third option. The final one is again a problem on trapezium. Here the area of the trapezium needs to be calculated. A circle is drawn inside this trapezium and its radius r is given. The sides of the trapezium are given, parallel sides of the trapezium are given as A and B. Looking at the diagram, we see that the diameter of the enclosed circle 2r forms the height of the trapezium. So directly use the data into the area formula to calculate the area of the trapezium. That is half into sum of the parallel sides into height, half into A plus B into 2r, which works out to be r into A plus B and is given as the fourth option in the question. Hope you have enjoyed these 5 geometry based questions. Let me meet you again in some other video discussing some different problems. Thank you.